So yeah, anyway, kind of back here, just checking out some of the different things. You can see with Rust, you have like unwrap or else, unwrap default, unwrap none, expect none, and these are kind of like all built into the standard library. And I was kind of just looking at um, the Rust iterators and stuff like that. Um, I thought they were pretty bad in terms of just the amount of bloat. So you can see like skip while, try, all these are like different try functions, which I just think are kind of unnecessary for a well-designed language. Like is sorted. I think you could just overload that function with the key instead of having like a different function. Um, I'm not entirely sure though. Function overloading versus just having a different method. Maybe you could also kind of just have a better documentation so that if you have variants of is sorted, like a prefix function like that, or maybe you have like a prime directive postfixed to the function name. That could just be like a drop down menu, so that you can go like you press the drop down menu and then it shows the other modifications is sorted by key. So even like the interface of the documentation could be quite good too. But right now, I think I'm just going to stick toward having different kind of matches or overloads for different things. Um, and yeah, type classes and stuff like that are pretty good too. Source contents. Maybe go to contents. Data foldable. Mm. I'm just kind of looking at different ways to, because you can overload different kinds of things. Just bring up Jupyter and look at Haskell. Oh shit. Okay. Well, let's close. Let's just close everything. Oh, maybe I have to update our camel. I think. Is it OPAM? Well, anyway, look. Where's Haskell? So yeah, I mean, function f, you take an a and b. Um, yeah, I guess it kind of just works. Print it though. Oh, I don't know what's going on here. I think we have to. I think it's print line string. Haskell. Put string line or some shit. Put string line. Oh yeah. Wait, how the hell do you just print? Fuck, I'm fucking retarded. Print. I think you have to just read it. Oh, okay. I mean, I swear to God, I mean, damn. Get line for streamline. Maybe you have to kind of. 10-4. Oh, okay. Um, you just do. Okay. Get line. Oh. Oh. Oh no, that's just the get line itself. Okay. Is that how? Okay, that's really weird. Can't you just do put string line where? Yeah. String line, return that. Yeah, can't you just do print? Uh. Oh yeah. So I think this definition overwrote that. That's kind of the thing that I didn't get. I think. Um. Yeah, because I'm pretty sure you could just show it. So that is a bit of an issue, I guess. Um. Does this work? Okay. So I guess you will have to match on the input itself. Uh, so you can't actually do that. Oops. Wait, what? I think you. Oh, okay. I think you have to wrap it around in parentheses. Okay. So I think it only allows you to match on the arguments only, which I guess it's probably fine. Enclosure, an actual like good language. Um, it's a bit different. By the way, do I have Mercurial? I think I'm going to try Mercurial as well. What's this? Hmm. Yeah. So you need to learn how to basically match and use the parentheses and the dollar sign, because the dollar sign is what allows you to kind of do some extra things. Um, syntax. Maybe it's here. Function application. So you can see what you're basically doing is you're applying f to A, and then using that result, and carrying it to B, then carrying it to C. But if you use the $sign, you're kind of reversing it. So I guess instead of just, sum, map, and square root, this actually kind of reverses. So it's sum, map, and square root. So I guess that's the same thing as I press insert. Okay. No. That's basically the same as doing this, which is basically the same as doing this. So you're kind of allowing it to, I guess if you kind of want to transition that into a more traditional language, the one without the thing, like without the parenthesis or the $sign, this will be basically equivalent to sum of map of square root in like a language like Java or something, I guess. And yeah, well, at least the map notation would probably be more like map x square root x. Yeah. So, I don't know, in JavaScript or some shit, you'd probably have something like that. And that would be a bit different to this, which again is equivalent to this. And in a traditional language, I guess that would basically mean map square root. Basically mean, oh wait. I think these are all the arguments of sum rather than like an inner kind of notation. So it's kind of like this, but it's also more like sum map square root, like that. And equivalently, you could write this as sum map square root. So that's kind of the general idea. If you try to do it it just won't work because it's assuming that you're kind of like applying sum to these three arguments, whereas sum isn't a function that takes in with three args. It takes in two args, this and this, and returns this. So it just wouldn't work. So it's a bit different, I would say, and I think it probably does take a while to kind of get your head around. And I guess similarly for this, you have something similar with your map, where that seems a bit interesting actually. I think it could just be, it basically just means another function. So map 3, like square root of 3, I guess. Third square root or some shit. Or 3 plus 4, 3 times 10, 3 to the power of 2, square root of 3. Okay, so that basically means this, you kind of want to apply these functions to this element, and you would kind of prefix it with a dollar sign. So yeah, you can see this is quite effective and concise, expressive is basically what I wanted to say. I think you do have something similar in Clojure as well, especially with macros. With macros, you can do so many different things, and that's probably one of the reasons why you didn't use like Lisp in the first place, is to define your own kind of abstractions and function things that kind of act like functions but are actually evaluated statically or take other programs in rather than like data or functions. It sounds kind of abstract, I guess, but it is kind of simple. It is kind of a core thing. It's not simple. Yeah. I didn't show too much. Yeah, just kind of looking at a bit more stuff, but I think that's kind of fine. And for our tensor kind of primitives, we want to represent both like arbitrary data, arbitrary specs, kind of like in the same manner. So we could use like the curly braces, brace notation, have something like Clojure. I don't know, A is mapped to 5, and A here is treated as an identifier, right? So if you say like capital A is defined as a data. I actually don't know how to explain this. Maybe I'll just call it like a tensor or a datum tensor or datum. It's defined as a datum that has a singular field, lowercase a, defined as 5. If you prefix it with an underscore, that becomes a private field, so you won't be able to access it like, if you a dot underscore a, this will give you an error. If you try to access it out of its own scope. So what that would mean is that wait, did my mic die? No, it's fine. Okay. What that means is that if you want to, define some kind of method, you would extend a, or I don't know, implement a, I guess. I'm not sure what I want right now. And let's say you just want to define some function called change a method. You will have to prefix that with a self, and then you would, like in Python, then maybe you'll have a new a, and that's would be, well, maybe let's just say you don't really care about what the type is and let it infer. And all you're doing is saying, look, self dot a is equal to new a. And what that would say is that what that would mean is that self, when you do a, let's say you create a default a and then you're doing change a, and you make this 4, that will change underscore a to 4 from 5. And similarly, you could also have something like a spec. So instead of just having a constant, you could a literal, I guess. Well, literal is pretty much constant, I guess. Literal is equal to constant, but constant doesn't necessarily equal to literal, I guess. That's what I mean. So it wouldn't be equivalent there. But let's say you assign this to an identifier. That's going to assume it might not be constant. Well, not really so much as. So it'll basically know that it might not be a constant, right? Now, that's actually in other languages. In Rei, everything actually has a default value. So string is actually defined as an empty string. And this is a key kind of fundamental factor on Rei, because nothing really is uninitialized, right? Uninitialized. I can't spell, man. Fuck. So, in C, if you have something like int I, this may or may not have a initial value depending on like the compiler. If you're using GCC, it might give it a initial value of 0. Maybe if you're using some other compiler like Intel, it might just give you some random number. There's no guarantee that this will be a constant way of representing a value in C. And the C standard doesn't define that, right? It doesn't define any kind of constant initial values. So maybe somebody else in the team uses a different compiler suite and they want to compile code. This could mean pretty much anything. So if you have a function void f, and you just defined some function, some value I, and then you want to return I, that'll be an int. Now most compilers would probably be able to kind of just set this to 0, and be done with it. But some compilers might set it to some random value, and if you're going to rely on this being 0 or some initial value, it's not a reliable way of doing so. In Rei, however, the standard does define that pretty much everything, especially the primitive data, has initial values. So there's bits, and the initial bit is just 0, right? So it's basically a tensor of rank 1. Tensor rank it'll be rank 0. 0 value equals 0. Well, that would be a bit. Bits would be tensor rank 1, 0. And this you can rely on, right? Same thing with string. String is basically just defined as bits. So if string is defined as not bits, but byte. And byte is just defined as, well, like just 8 bits, I guess. Prefix that with a B. I think a 0B. Postfix that with a underscore B. And that's all that means, right? So when you create a string, all you're doing is you're creating a vector containing 1 byte, and that's 8 bits. So essentially, and when you're creating like a new int, unsigned int, that's essentially that's essentially just a numeric, but with extra kind of stuff. Numeric is essentially just the same idea as byte, but it's not a vector. It's just a variable length byte. Actually, I'm not sure about this representation. I think I'll change it later, but it's kind of like basically the idea is that it's going to be like a variable length byte or set of bits. So when you're creating a value like numeric 3 or just numeric, like the default numeric, this actually specifically means that, right? Whatever numeric is defined as the initial value. So what that implies for the rest of the program and language is that every class, everything, when you kind of initialize it or use it at all, even with like the default kind of thing, it's always going to have a default value, and it's always going to be static, so you know exactly what it is, and that's defined in the standard itself. So that's kind of one thing. There's no such thing as like uninitialized things. You can't like just randomly, and you know it's kind of just there to solve things like that, or you know char a 500. You know what's that going to mean, right? Is that going to be zeroed at runtime, or is that it's going to be uninitialized, right? So there are pros and cons to each. Pros are static analysis, safe to reason about, force you to make decisions, good code. The cons though, overhead on initialization and creation of data. And that's one of the reasons why you'd probably have something that's uninitialized, so that you can, you know, just allocate the data, maybe just push down the stack pointer, right? Push stack pointer, done. That's all you have to do in a language like C, but in Rei, you will have to zero them out, or assume zero. Assume zero or certain value during analysis and program and execution. So that's one of the differences. And yeah, look, that's probably one of the reasons why you want to use dynamic data structures that don't have like complete upfront creation costs. So you know, use by need. What I call use by need basically means allocate when you need them, and then cache by creation. Cache aggressively and kick out old stuff aggressively. And with the two kind of philosophies combined together, what you would have is that you would have something that's essentially lazy evaluation, um, which allows you to kind of balance out the overhead of data generation, initialization, and memory usage. And encourage use of dynamic data structures and simpler data structures. Because again, if you don't have to worry about like your memory kind of requirements and stuff like that, and then you have aggressive caching and kind of policies and kicking out kind of old stuff, you don't have to worry about exactly what allocator and stuff like that you have to use. So your data structures can generally be much simpler and much more kind of intuitive, and probably just better prone to compiler analysis, right? Because simpler probably allows more effective optimization by compilers, optimizer, compiler. And that's kind of the thing. If you want to minimize spikes, and by doing so, smoother experience the user, and possibly just better in general for the hardware, but in terms of not having to overload or underload too frequently, so we can maintain a steadier increase. Perhaps increase its lifetime too. Heat generation. So there's also other things like lifetime and heat generation that I feel like a lot of people don't really consider at all. When I'm thinking about new hardware, I'm thinking about as many things as possible. And one of the things I kind of thought about was just the fact that, look, I mean, if you're going to have something that tries to do a whole bunch of things at once, like allocate 500 megabytes of data in one go, and write to it all in one go, you're probably going to go from 0 to 1. You can easily go from 0 to 100 in terms of the hardware utilization. That might affect other programs running on the system, and that could like have ripple effects on other things, right? So that might create things like bottlenecks. So this is one of the ideas behind Rei. Rei is Greek for flow. Panta Rei, everything flows. We want the whole kind of system to flow. We don't want to create like bottlenecks in one area, or have too many kind of things going on all at once. And I think that's one of the really key ideas. It's to really just not to have things that are done in a very kind of strict or things that try to abuse certain concepts of memory allocation and really just resource usage in general. You don't want to increase resource utilization too quickly. And this is one of the things I really noticed, because stable 25 FPS is much better than getting unstable FPS in the range 30 to 80. Right? Because when you get like when this happens, it just feels really kind of bad to play. You feel like you're missing things. It feels like it's stuttering. It just doesn't feel fun, and you do notice it, right? So even though it's like higher on average, the experience might still be much poorer than just having something that's stable. And I think this is one of the things that people don't really consider too well. So this is kind of one of the things that I'm kind of really taking into account more and more, I think, as I go into this language, is to how do you have something that's a bit more smooth in terms of smooth flow, and resource different and rate of resource. Maybe like differential, like differential resource utilization. So smooth differential resource utilization, I think, will be a key factor here. That being said, though, I was going to talk a bit more about maybe some of the functions and some of the expressiveness of it. Right now in Rust, what I'm doing is I'm kind of doing, look, you have an enum that's representing your data, and the data could contain either more data, and you kind of have to well, you could probably represent that as a vector, or you could have well, just like an actual like field itself, right? And a field could either be like an actual value, like a literal value, so like a number or a string, or it could be like an indirection, right? And the idea is that, well, an indirection could refer to it's basically like an identifier. And here, having more data just means, well, you map this kind of identifier or whatever to more data. And so, by doing this, you're able to kind of represent arbitrary amounts of, well, this idea here in a pretty smooth way, I'd say. I am using Rust so that it's not entirely efficient to do, but I think it's good enough. And and one of the things is that you can't have anonymous enums. It just feels so bad because anonymous enums would be so good. Yeah, I mean, anonymous enums are just. It really just sucks how we don't have these enums. I think some people have tried to make make libraries for it, but it kind of just is what it is, I guess. And you can match X. Do you even need like an enum for this? I think you can already do that without. I'm pretty sure you could do that without. How about just like returns another I64? Yeah, I mean, I'm pretty sure you could just do that already. So I don't know what the hell's going on here. Maybe it's just the fact that you could use that a bit further. Maybe nest your enums or something like that. But yeah, what I was talking about is I want to have like an anonymous enum where you could have that either as like a field, in like a tuple, or a variant. So that would just kind of be better, I would say. But I don't know. I mean, I think it does work. And then with this, you could even represent vectors, right? You can represent lists and stuff too. Because remember, list, one, two, separating the idea of like a list of a certain element t with like a tense, like a tuple, I guess, with a t, like a tuple. It's not really that big of a deal, I think. Like maybe you could just make this a higher level kind of thing that's defined as basically a tensor, and then maybe do something there so you could have something a bit better. But I think for now, I don't think it's really that important, especially since you could probably do a bunch of static analysis on it and really do it. So I think that's fine, and I'll probably talk a bit more about this later.